and I can give you the chance to make a presentation. Okay, so please write down in next 2 minutes who could not make a presentation in the last class. Dinesh, you just note it down, and Tuli has not joined yet,
Okay,
right?
sir. Yes, sir.
Hmm.
Sir,
Yes.
sir, one of my fellow mate is not able to join.
Who is that?
Is Chandrakanto. He must be waiting in the lobby.
No, I could not see him. So you ask him to try to join again. Okay. I cannot see him that he is waiting for joining.
Okay, sir.
Only two? Three, Shorjan. Yeah? Group for Avilash and Arnab. All right. So just write down the name, and Dinesh is noting it so that he can ask for to make a presentation. But meantime, what I'll do is, you know that in the last class I spoke about milling machine. So milling machine is a versatile machine with the help of which we can have number of operations. Like if you want to have a flat surface, then we can make we can make the use of milling machine. On the other hand, for making a flat surface, you learned the operation of some other machine. Can you tell me what is the name of that machine for making a flat surface? What are the machines by which we can make a flat surface?
So shaping machine.
Shaping machine and any other machine?
Planing machine.
Yes, and planing machine, shaping machine. That's good. And what else? Which other machine? Shashwat Agarwal, which other machine we can use for making a flat surface? Shaping, planning. Oniket, do you have any other name of the machine which can be used for making a flat surface?
Sir, plain
No, sir, I
milling.
cannot.
Huh?
Sir, plain milling.
Okay, plain milling, whatever milling, it's all right. But no, grinding is a finishing operation. It cannot machine, right? Everybody is making naming shaping and milling machine, but there is another machine which you have, operated, and you know which machine. Just think of it.
So slotting machine?
Slotting.
Yes.
হাতের সামনে পেলে না তোকে মারতাম বুঝিস অনিশ look Supratik, yeah, why you are saying lathe? Supratik,
I think so. We have learned about the lathe machine, and in lathe machine we can complete various types of operation. I think we can make flat surfaces.
how flat surface?
Like there is some tool by which we can make flat surfaces. We have.
Onesha, do you agree that lathe can be used for making a flat surface?
No, sir. I don't
Hmm.
agree.
Ritik,
Sir, I think, sir, there was an operation that is called the facing. By using the facing operation, we can make the flat surface in the lateral face of the cylinder.
yes,
But
Apurvo,
that is on a peripheral surface, not on the
Apurvo,
on the body.
Yes, sir. Yes, yes.
Sir, make the flat surface on the lathe by the other attachment like forge jaw, chucks, or other machining process.
very good. So it is possible with the help of a lathe. So what you do is, oh, I'll show you a picture which will help in understanding. Uh, just 1 minute. This.
Look, this is called lead, and this is the very basic.
No,
This is this screw, or on the other side the screw. We can adjust the
not here. I wanted to show you a photograph where it can be seen. Shipping, thread cutting. Okay. No. However, I was just trying to find out some photo. Lathe with chuck. Can you see the photos?
Yes, sir.
Yeah. So, we call these as chuck, three-jaw chuck and four-jaw chuck. And this is mounted on the lathe in place of the faceplate. You remove the faceplate and you can fix it. Now, what we do is, you fix the job here. Okay. And fix the job with the help of this jaws. It can be 4 jaws, it can be 3 jaws. 3 jaws can automatically come to the center, and 4 jaw you have to make the center. So fix the job here with a protrusion of some portion of the job beyond the chuck, and then you start rotating the chuck. 1 minute.
hey, I am going for a vacation where
Oh.
I'll be totally cut off from my 3-jaw universal chuck.
I'm taking this out. So you have seen the chart, and then I am making a presentation of another view. Can you see this? Is it visible to you, all of you? Yeah. So you know that this is the chalk. Now this will fit to the machine. These are all internal constructions, so you may just see this. This will be helpful for you. Yeah. And now it is assembled, and this is the lathe with the help of which, I mean, the chalk is now fitted. Okay, and you fix the job. So somebody was telling that facing. So you know that this is the face of the job, and if there are undulations, so what you can do is you can fix the job like this. You are fixing with these jaws, and then start rotating the job and use the tool, and then 1 minute. No, not this. Yeah, you fix it up. Use the tool, and the tool will cut this portion. So this portion means you are now making the surface flat. Right. So this is an operation which is called facing operation, but on the other hand, this is also called for making the flat surface. So now if this job is a square face, and you can fix it here, and the square face or the bar or any shape of the job that can have a good finishing on the flat surface. So in that way, lathe can also be used for making a flat surface. So I'm just leaving it now. So we can use a lathe, shaping machine, planing machine for making a flat surface. So could you understand how a flat surface can be made in the lathe? Yes or no?
Yes, sir.
Manish?
Yes, sir.
Yeah.
Sir, if the job rotated, then how the flat surface is made? The spindle is rotating in lathe.
Spindle is rotating, and you are putting the tool on the surface and giving the depth of cut. So, and giving the depth of cut as well as giving the feed on the tool. So whenever tool feed is given, that is approaching towards the center and with a particular depth of cut. So a new surface is generated on the face, and that is making a flat surface.
So then only sir face surface can be made.
Face,
Lengthwise,
I'm not discussing about the length. I am discussing only about the face or the flat surface. If you want to make a flat surface on the length, then you have to orient or fix the job accordingly.
yes,
You have to rotate the job and fix the job in the chalk so that the diametrical portion or the cylindrical portion comes onto the surface. Only a part of it can be made a flat surface, right?
yes,
Say a cylindrical surface is to be made flat with the help of a shaping machine. What you will do? You will fix the cylindrical surface top and the face on both the sides and fix the job, and then start the operation for movement of the tool, and the surface will be generated. The similar thing, the job has to be fixed on the chalk in the similar manner so that you get the exposed cylindrical surface, which will become a flat surface. Some of that portion will become the flat surface, right? So it is possible that with the help of lathe, shaping machine, milling machine, you can make flat surface. Now you can make flat surface with the help of milling machine also, right? So last day I showed you the operations of milling machine by which you can have number of operations, and like you can cut the side, and the side face also can be cut with the help of milling machine. Then top surface, then you can also make the gear with the help of milling machine. But usually gear cutting is done with the help of milling machine. You cannot cut gear with the help of shaping machine or drilling machine or any other machine. But milling machine is the only possibility that you can cut gears at a very faster rate. There are a number of types of drilling machine, milling machine. So today I'll show you one video which will help you in understanding what are the types of milling machine available. First you see this. Okay, I'll show you another video.
In this video, you'll learn what is milling machine and how it works. Its parts, types,
Sir, you are not presenting.
Yeah, I know that. Now it will come. You can see this? Can you see this?
Yes, sir.
Yeah. So I'll now start it. Okay. Please note it down also. It will help in understanding how the milling machine works, what are the name of the parts, what are the types of milling machines, and the operations. I'll not show you the operation because operation, the schematic operation I showed you in the last class, but today I'll show you the full operation, how a gear can be cut.
applications, and more.
Oh.
The process of machining using rotary cutters. To remove material by advancing a cutter into a workpiece. This can hold more than one tool at a time. The cutter rotates at a high speed and has many cutting edges, and it removes metal at a very fast rate. The milling machine can also hold one or more number of cutters at a time. It is one of the most important machines in the workshop. All the operations can perform with high...
See, all the tools are there. Each of the tools can be used for different operation. I mean, each of the tool has a specific operational advantage, and each of these can be used in the particular milling machine.
Accuracy. The metal removal rate is high as compared to a lathe machine, planer machine, and shaper machine.
Yes.
It has good accuracy and better surface finish, and it is widely used in various production works. Now let's find out the different parts of milling machine.
Don't call me.
Base, column, saddle, table, overhanging arm, front brace, spindle, and arbor. The base of the machine is gray iron casting and serves as a foundation member for all other parts which rests on it. The base carries the column at its one end. The column is the main supporting frame mounted on the base. It is box-shaped and houses all the driving mechanism for the spindle and feed table. The knee is a fixed gray iron casting that slides up and down on the vertical ways of the column face. The adjustment of height is affected by an elevating screw mounted on the base that also supports the knee. The top face of the knee forms a slideway for the saddle that gives cross travel to the table. The saddle is placed on top of the knee, which slides on guideways set exactly at 90 degrees to the column face. A cross feed screw is used to move it horizontally. The top of the saddle is precisely machined to provide guideways for the table. The table rests on guideways on the saddle and travels longitudinally. A lead screw is provided to move the table horizontally by hand or power. The longitudinal travel of the table possibly limited by fixing trip dogs on the side of the table. Overhanging arm is mounted on the top of the column. It extends outwards the column face and works as bearing support for the arbor. Front brace is the extra support that provides rigidly to the arbor and the knee. The front base is fitted between the knee and overarm. The spindle of the machine is located in the upper part of the column and receives power from the motor through belts, gears, and clutches and transmitted to the arbor. The accuracy in metal machining by the cutter depends on the strength, accuracy, and rigidity of the spindle. Arbor is an extension of the machine spindle on which milling cutters are securely mounted and rotated. These are made with taper shanks. The arbor may be supported at the farthest end from the overhanging arm, or may be of cantilever type, which is called stub arbor. Now let's find out how milling machine works. The working principle of the milling machine applied in the metal removing operation. The work is rigidly clamped on the table and revolving multi-teeth cutter mounted either on a spindle. The cutter revolves at a normal speed and the work fed slowly past the cutter. The work can be fed in a longitudinal, vertical, or cross direction. After the work is fed, the cutter teeth remove the metal from the surface to produce the desired shape. Now let's find out the different types of the milling machine. Column and knee type milling machine. There are 5 types in column and knee type milling machine. They are hand.
So I believe that you have seen the name of different parts in milling machine. So do you have any problem in that, in understanding? Anybody? I am asking you guys that is it clear the different parts in a milling machine which is described now?
Yes, sir.
Yes, sir.
All right. So now see the types of milling machines.
Milling machine. Plane or horizontal milling machine. Vertical milling machine. Universal milling machine. And omniversal milling machine. 2. Manufacturing type or fixed bed type milling machine. In this there are 3 types. They are simplex milling machine, duplex milling machine, and triplex milling machine. 3. Planar type milling machine. 4. Special type milling machine. In this there are 7 types. They are rotary table milling machine, drum milling machine, profile milling machine, planetary milling machine, tracer controlled milling machine, pantograph milling machine, and NCCNC milling machine. 3 types. They are hand milling machine, plane or horizontal milling machine, vertical milling machine, universal milling machine, and omniversal milling machine.
Yeah, can you tell me what are the types of column and knee type milling machines? Anybody? Onesha, just read this. What are the column and key type milling machines?
Yes, so hand milling machine, plane or horizontal milling machine, vertical milling machine, universal milling machine, and omniversal milling machine.
Yeah, so this B, C, and D, mainly these 3 type of milling machines are used in quite a good number. Okay. And these are all special type milling machine. Can somebody read what are the special type milling machines? Ritik?
Yes, sir. Rotary table milling machine, then drum milling machine, profile milling machine, planetary milling machine, tracer control milling machine, pantograph milling machine, or NCCNC milling machine.
Yeah, mainly in E, F, and G, you have a template of the job which you will be cutting, and the template is stressed by the special part of the milling machine, and accordingly the job is cut by the tool. So these are all gives a good surface finish as well as the good shape which you desired, and these are not traditional shape of the job, so that's why the tracing or pantograph is used.
Column and knee type milling machine. The column and knee type is the most used type of milling machine for general workshops. In this machine, the table is mounted on the knee casting, which in turn mounted on the vertical slides of the main column. The knee is vertical and adjustable on the column, and the table can be moved up and down to accommodate work in various heights. Hand milling machine. It is simplest type in all of other milling machine. In this, the table feeding is controlled by hand. The cutter is mounted on a horizontal arbor and is rotated by power. This type of milling machine is small in size and suitable for light and simple milling operations. For example, machining slots, grooves, and keyways. Plane milling machine. These are much stronger than hand millers. The table feeding is done either by hand or power. The plane milling machine having a horizontal spindle is also called as a horizontal spindle milling machine. The table may be fed in a longitudinal, cross, or vertical directions. Universal milling machine. It can be adapted to a wide range of milling operations. Here the table can be swiveled to any angle up to 45 degrees on either side of the normal position. In addition to 3 movements, the table may have the 4th movement when it is fed at an angle to the milling cutter.
And here in this universal milling machine, we have also one such in our machine tool research laboratory. You know that this table now is horizontal. Let's say you need to make the table at 30-degree inclination, you can make it with adjustment, and the job can be set here and the milling operation will be done. So there is a lot of flexibility in this universal milling machine. You can swivel this table.
Helical milling operation can also be performed. This machine can produce spur, bevel, spiral, twist drill, reamer, milling cutter. All operations that are performed on a shaper can be done using a universal milling machine. Omniversal milling machine. Here the table has 4 movements. It can also be tilted in a vertical plane by providing a swivel arrangement at the knee. The additional swiveling arrangement of the table helps in machining spiral grooves in reamers and bevel gears. Vertical milling machine. Here the position of the spindle is vertical or perpendicular to the table.
See here, as long whatever you have seen, the arbor was there with the machine where the tool was fixed. So in that way, the arbor was horizontally set. But here, instead of arbor, there is a spindle which is vertical, and that's why it is called vertical milling machine. And this looks like a drilling machine. Like drilling machine, the spindle is also vertical. Here the tool fixation system is vertical and the job is here.
This type of machine is adapted for machining grooves, slots, and flat surfaces. The machine may be of the plane or universal type and has all the movements of the table for a proper setting and feeding the work. The spindle head is clamped to the vertical column, which is swiveled at an angle, it allowing the milling cutter fixed on the spindle to work on angular surfaces. Manufacturing or fixed bed type milling machine. These machines are large, heavy and rigid in construction. These machines differ from column and knee type milling machines by the construction of its table mounting. The table is mounted directly on the ways of a fixed bed. The table movement is restricted to reciprocating at a right angle to the spindle axis with no provisions for cross or vertical adjustment. It is classified as simplex, duplex, triplex based on a machine provided with a single, double and triple spindle heads respectively. Planer type milling machine. This type of milling machine are also called as plano miller. It is a massive machine used for heavy-duty work. These are having spindle heads adjustable in the vertical and transverse direction. This machine has a cross rail capable of being raised or lowered carrying the cutters. It has their heads and the saddles, all supported by rigid uprights. This arrangement of driving multiple cutter spindles enables a number of work surfaces to be machined. Thereby it obtains the great reduction in production time. In a planer, the table moves to give the cutting speed. But in a plano milling machine, the table movement gives the feed. Special types of milling machine. Milling machines of non-conventional design have been developed to suit special purposes. These machines has a spindle for rotating the cutter and provision for moving the tool or the work in different directions. There are various special types of milling machines available in the workshops. Rotary table milling machine. Here the table is circular in nature and rotates about a vertical axis. Here cutters are set at different heights, which results in one cutter roughing the workpiece and other one cutter finishing them. The advantage of this machine is that continuous loading and unloading of workpieces can be done by the operator while is in progress. Planetary milling machine. Here workpiece is held stationary while the revolving cutter. The cutter moves in a traveling path to finish a cylindrical surface on the workpiece, either internally or externally. This machine is also adapted for milling internal and external threads. Pantograph milling machine. A pantograph machine can duplicate a job by using a pantograph mechanism. It allows the size of the workpiece reproduced to be smaller than, equal to, or greater than the size of a template. A pantograph is a mechanism that is generally constructed of 4 bars or links, which are connected in the form of a parallelogram. These machines are available in 2-dimensional and 3-dimensional models. Profiling milling machine. A profiling machine duplicated the full size of the template attached to the machine. Here the spindle can be adjusted vertically and the cutter horizontally across the table. A hardened guide pin regulates the movement of the cutter. The longitudinal movement of the table and the crosswise movement of the cutter head follows the movement of the guide pin on the template. Now let's find out the various operations that can be performed in a milling machine. Plain milling operation. This is the most common type of milling operations. Plain milling is performed to produce a plane, flat, and horizontal surfaces. It is also known as slab milling. The work and the cutter are secured properly on the machine while performing the cut. The depth of cut is set by rotating the vertical feed screw of the table, and the machine is started after selecting the right speed and feed. Face milling operation. It is the simplest milling operation, performed by a face milling cutter rotated about an axis perpendicular to the work surface, and carried out in plane milling. The cutter is mounted on a stub arbor to design a flat surface. The depth of cut is adjusted by rotating the cross-feed screw of the table. Side milling operation. It is the operation of producing a flat vertical surface on the side of a workpiece by using a side milling cutter. The depth of cut is set by rotating the vertical feed screw of the table. Straddle milling operation. It is the operation of producing a flat vertical surface on both sides of a workpiece by using 2-side milling cutter mounted on the same arbor. Distance between the 2 cutters is adjusted by using suitable spacing collars. The straddle milling is commonly used to design a square or hexagonal surfaces. Angular milling operation. The angular milling is the operation of producing an angular surface on a workpiece at right angles of the axis of the spindle. The angular groove may be single or double angle, and may be a varying included angle according to the type and contour of the angular cutter used. One simple example of angular milling is the production of vid blocks.
And you know that this V-Block we also manufacture with the help of a shipping machine. And but the shipping machine, this angle production of this angle is will take a lot of time, whereas in milling machine it gives the shape with the help of a form cutter. This is the cutter. There may be a standard cutter or availability of the form cutter as we check with the angle. So in that way, this will help in reducing the operation time of the job on the job.
The axis of the spindle. The angular groove may be single or double angle, and may be a varying included angle according to the type and contour of the angular cutter used. One simple example of angular milling is the production of V-blocks. Gang milling operation. It is the operation of machining several surfaces of a workpiece simultaneously by feeding the table against a number of cutters, having the same or different diameters, mounted on the arbor of the machine. The method saves much of machining time and is widely used in repetitive work. Form milling operation. It is the operation of producing the irregular contour by using form cutters. The irregular shape may be convex, concave, or of any other shape. After machining, the formed surface is inspected by a template gauge. Cutting rate for form milling is 20% to 30% less than that of the plain milling. Profile milling operation. It is the operation of reproduction, an outline of a template, or complex shape of a master, dies on a workpiece. Different cutters are used for profile milling. An end mill is one of the widely used milling cutters in profile milling work. Other than these, there are also various operations performed, such as end milling, saw milling, keyways, grooves, and slot, gear milling, helical milling, cam milling. Thread milling operations are done in milling machine. That's it. Thanks for watching. If you like this video, then please share.
So, is it clear to you what are the different types of machines and different operations? Hello?
Yes, sir.
Yeah, and I also showed different operations in the last class, possibly. Is that right?
Yes, sir. In the first class.
Right, first. So, this is basics of milling operation and milling machines. But now I'll show you, because you know that there are different types of operations you have seen which can be performed on a milling machine. And there are several operations which can be performed in other machines, like as I was referring to the V-shape, V-block. We have a V-block job on shaping machine for third year class. In that way, V-block can be manufactured with the help of shaping machine, but on the other hand, that can be also done with the help of milling machine. But in the milling machine, you know, the tool is very expensive. So in that way, if you are to make a 30-degree angle, then the special purpose tool is also manufactured so that it has only 30-degree. So with the help of that tool, you can make only the 30-degree job. If it is 40-degree, 45-degree, then you cannot make it. But on the other hand, in shaping machine, there is no limit of the angle. More flexibility is there, that if you swivel the tool head, then you can fix any angle. So these are the flexibility, but parallelly it takes long time if you do it on the shaping machine, and the cost is also less in shaping machine. So now the main important thing for milling machine is cutting a gear. You know what is gear? Do you know what is gear? Ritik,
Yes, sir.
you know what is gear? Yes or no?
Yes, sir.
Chandrakant,
Yes, sir.
you have seen the gear, no? And
Yes, sir.
whenever the class is at 11 o'clock, it is the discipline of all that one must join at 11 o'clock. Right? And from the
Yes,
next,
sir. But
from
I
the
am not
next day, I
able to
allow
join with the WebEx link. So
this platform because everybody must maintain discipline. Okay, so you must also learn discipline. Yeah, Chandrakant, why you were joining in WebEx when it is written in the chat box that we will go for Google Meet? So that is a lame,
sir,
that's a lame
sir,
excuse. And
no, sir.
I know you
First,
because I know you because you had been also in my class in your design. You had a design
yes, sir.
subject in the last semester, so I have the experience
Yes,
with
sir.
of holding classes with you. You should be very sincere in the class and disciplined. All right. Yeah. So
Yes, sir.
now I'll show you how a gear can be cut. But please be sure that you learn from this and note it down. Mainly how, whether it is 20 teeth or 27 teeth or 40 teeth, how this can be set in a milling machine. It is shown very nicely. So in that way, you must learn it very carefully and sincerely. Hmm. I'll show you that. Hmm. Gear cutting. Where is that? Gear. Yes. Mm. Okay. Can you see someone?
Yes, sir.
All right. So now I'll start it.
Making a gear for a Bridgeport head. This is for the feed gear, one of the feed gears in there. I don't know exactly where it goes, but viewer asked me if I could help him make one. He actually made a blank for me, and my job is going to be to cut the gear teeth. And we've already, in a previous video, we've machined a mandrel that we'll use to hold this in place over on the grinding head. So that we can actually cut those teeth. If you haven't already, please go back and watch that video. And with that, I'm going to bring you over here and show you a little bit about this gear. And we'll go ahead and start cutting some teeth. So again, I'm over here on my worksheet, and this is a little Excel spreadsheet that I created a while back when I was doing some gear cutting, and it's just something that helps me get all my measurements. I got all the equations and stuff to do all my calculations right out of the machinery's handbook. You can do them all by hand. With this spreadsheet, basically all I have to do is put in the pitch, which I've already measured it. It's a 16 pitch, diametral pitch. My number of teeth is 27, and my pressure angle is 14.5. Now, from that information, it can calculate and tell you just about everything you need to know about the gear that you're cutting, which is really kind of remarkable in itself. We know the outside diameter of it should be 1.813, and measuring this with the calipers. Yeah, I'm getting 1.812 and a half, probably depending on where you put it on here, but it's right on the money. It's good enough for what we're doing. So that looks good. This tells me what cutter I need to use. So in the involutes, this is an involute cutter, so it has the profile for the gear tooth. And they make these by the pitch. So for 16 pitch, there's actually 6 cutters. And depending on the number of teeth that you're cutting, you'll use a different involute cutter because the shape of that tooth actually changes as you increase or decrease the number of teeth. So in this case, we need a number 4. This is a, probably can't see it, but a number 4 16 pitch. And somewhere on there it tells me it's a 14.5 pressure angle right here, 14.5 PA. So that is the correct involute cutter that we need. Now, my depth of cut, once I start cutting, according to this, we actually will calculate in a little bit of backlash, and we want about 3/1000ths of backlash in it, which again, that's right out of Machinery's handbook. You don't want the gears to be too tight. So my depth of cut to obtain the backlash is 137 thousandths. So we know that we're going to have to go that far. What I'll probably do is I'll set it up. We'll probably take 100 thousandths cut, measure everything, and then for the final cut, instead of just going off this number, we'll actually measure across the pins here to actually get the diameter. So it will tell you what size pin you need. We need a pin diameter of 105 thousandths, and there's again a formula to determine that. I've got 2 105 gauge pins here. So what we'll do is we'll lay those on there, depending on whether it's an odd or even number. If it's even, you go directly across. If it's odd, you go just a little bit to one side. There's a little bit different formula to use, depending on if it's an odd number of teeth or even number of teeth. But it tells you right here that the measurement over the wires with the backlash alignment using that size pin is a 1.816. So after we do our first cut, we'll come in here, we'll measure that, and we'll see how far we need to go to get to our final depth. We'll dial that in on the milling machine, and then we'll recut the teeth to get to that depth. You know, if I was making multiples of these gears, I could get my machine set, and I could probably just take the whole cut in one pass. But in order to set the machine up, I really need to make 2 rounds to get it right on. Again, if I was doing mass production, you know, you could just do it all in one pass. So anyway, that's where we're here. We got everything ready that we need. Let's go over to the mill machine, get it set up with the dividing head to start cutting what we need. Got my dividing head up here on the milling machine, and we're going to go ahead and chuck this piece in here. And we're just going to put it into the 3-jaw chuck, get it good and tight. And now, our washer there, and tighten it in place. Alright, it's got that held firmly in place now. We just need to get our footstock on here to support it on the other end. So we got our footstock installed now, and I loosened this back up and got everything in line, so we're good to go there. Everything's tightened back up, so that's done. Next thing we need to do is get the right index plate in here for cutting 27 teeth. And I went and looked at my chart, and the one I need to do that is actually a plate that has a 27 hole pattern in it. So I got a 27 on this one. The one that's in here is not a 27. So I need to change these plates out real quick. So we'll just take this apart and do that. We'll start by taking the handle off. There's a clip here that holds the scepter on there, so we need to take that out. Let me knock that clip out. Alright, we'll pull the sector out. And then we'll remove the screws on this plate. And now we can knock this one out. There it comes. Set that one aside. trying to line up my screw holes back there. Let's get all these started and then we'll get it in all the way. Alright, got that plate back in there. Next thing that goes back on is the sector. And let me look and see. I know it's 1 revolution in some number of holes. Alright, it's 13 holes. So I'm going to go ahead and adjust this. Grab a Sharpie pen. Alright, so this is the 27 line here. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We started on this one. Loosen the screw up. And I'm going to spread this out over here. And you just use this little piece here to help you get on the right tooth each time. So that's now set. Put our clip back in here that holds us in place. There's a little detent here. So I'm going to put that up. And we'll just press that down. That's in place. And put our handle back on. And we'll tighten that back up. And then we need to make sure we're in the right hole pattern and we're off one. So let me loosen this up. And I'm going to slide this down. We'll get that one into the right pin there. And tighten it back down. Alright, so I'm going to pull this around here. And to get our 27 teeth, we'll do 1 full revolution and then 13 holes. Well, there. I'm not doing it for real now. We'll move our scepter around. This little tight one. And there. So on and so on and so on. So we're ready to start building our arbor now. I've got a 1-inch arbor here. Just wipe that down. Make sure there's nothing up inside there. Put this on. I'll tighten up the drawbar on the back. Go ahead and pull some of these bushings off and we'll get a cutter in there. I want to be turning in a counterclockwise direction so that I'm feeding, my cutter is cutting into this down here. So got my cutter properly positioned, get it up on the key here. Alright, now I take my bushings, or my spacers rather, put them back on here. This is my bushing that will right up in the overarm support. And we'll go ahead and screw this on here. Now, I'm not going to tighten this until I get my overarm support in there, because if I try to tighten it right now, I got a long lever coming out here and it can bend this shaft one way or the other. we can put the overarm support on there, and then that'll be supporting it, and I can tighten it up. So let me run my overarms out. And then we'll take our overarm support, put it onto the top up here. I like to go ahead and tighten that down. And now, so trying to get it lined up on 3 points, the bushing here as well as the overarms all at the same time, we'll just pull it onto the bushing and it'll kind of self-align on there. But before I do, I'm going to squirt a little oil up in there just to go ahead and get me started with some. Alright. Now I'll just pull the overarm support onto that bushing, slides up on there just as nice as can be. And that's good. And I'll tighten down the overarms on the top now. To the point now where I'll need to go ahead and get my cutter centered up onto the shaft here. We've got the involute cutter, everything set. This is the method I do. Every time I do this, I have people tell me this isn't the right way of doing it. This method's always worked for me. I know a lot of other shops that use this. And basically, we're just going to find the top of that shaft by finding where it hits out on there. So just eyeballing it. I'm very close to being right in the center. I'm going to raise this up until I just barely start to get a cut on there.
Yes. Yes.
Sir, actually we are having some problem understanding the American accent. We are not able to understand the American accent in which he is speaking English.
Who is that? We or I?
Sir, we.
We means who has a problem? Write down in the chat box who is having problem in understanding the accent. Write down in the chat box the name of you who is having problem in understanding. Yeah, so nobody else excepting you. So you have to maybe, however, if you have problem in understanding, you listen to this at least 5 times, because you know that you cannot be only a Bengali guy. You maybe your mother tongue may be Bengali, but English need to be understood very carefully. So you have to understand that, right? You have to try to make yourself understand the accent. I mean, there is no new thing which is there. So tell me where you have a problem. Understanding which part you have a problem, just let me know.
So in the beginning, he was changing a disc with so many holes. I didn't understand.
You don't need those. You mainly, okay, I'm just looking into it. Where? This is 13 minutes. Yeah.
Head, so that we can actually cut those teeth. If you haven't already, please go back and watch that video. And with that, I'm going to bring you over here and show you a little bit about this gear. Number of teeth is 27. And
is it clear to you, this table? This table, is it clear to you?
Sir, is there any relation about what type of cutters we have to use for making the gear teeth?
No, you can fix up any. I mean, you can be given, like say 10 dp. You can be given any task, and accordingly you have to set the tool. A tool must have a dp, and you must know what is the number of teeth to cut. And of course, pressure angle is not necessary for this for calculation, but you must know some of the parameters, and those parameters, whoever read gear, they should know it. Of course, there is a relation, but that relation is not impacting in this machining. So he is showing that these are the gear measurement parameters. Of course, as a third year student, you must know all this because you have also designed the either designing or you will be designing the gear, spar gear. So you must know all this. This figure you must be very clear to you. You should be knowing this figure.
Yes, sir. Actually, I'm asking that regarding the number of teeth that we have to make on the gear, and is there in relation that what type of cutters we have to use with respect to that?
No, the cutter which you are to use, that depends on the diametral pitch, but with the same cutter you can make say 20 gears, 20 teeth, 25 teeth, 40 teeth, that doesn't matter, but the setting of dividing head will dictate how many teeth will be cut. That has not come yet, so you please listen carefully, you will understand. If you don't listen carefully and sincerely, you will never understand whether it is American language or British language or Indian language, right? You must be very sincere about listening, then and not necessary that you have to understand all the words, because this is a videograph, the visuals are there, so you have to understand from the visual things, and some of the language you have to understand, and you let me know where you are not understanding. All right, could you understand what I said?
Yes, sir.
Yes, sir.
This is a very good explanation video, that's why I have selected this to show you. And you are saying that you are not understanding language. Saying no is very easy for a person who is insincere. So make saying no tough for you, that so that you try understanding, because you will not in the third year class for your lifetime. You have to move, you have to improve, and you have to understand also. Try understanding. Where there is a problem, let me know. I think that you understood what I said. Let me see how many wrote here. Aniket, Supratik, Orpon, Ritik, Kiran, Khijir, Sohini, Onnesha. Okay. So let me know first your background. Ovilash, you are from which school? Avilash?
Sir, I am from Bardhaman Municipal High School.
Yeah. So you had your English language in your class 12, 11, 12, 10?
Yes, sir.
Yeah. Do you hear English movie, enjoy English movie?
Sir, no, sir.
Yeah. Do you listen to the English news?
Yes, sir.
Where?
Sir, English news, sir, from mobile phone.
Yeah.
From
Which
YouTube.
which channel?
From YouTube.
Which channel?
Sir, from YouTube, I heard the English news. Sir.
Acha. Shashrat Agarwal, you are from which school?
Yes, sir. Sir, Birla Bharti.
So Billa Bharti, you had your language English or Hindi?
English.
English. I don't think that it is a problem for you. You have to try. Yeah.
Sir, actually he was speaking so fast and the accent, it was a little difficult to grasp.
Something, I mean, you know that whenever you took bath, after some time, walking was a problem for you. Is that right? But you learnt it.
Yes, sir.
You have to start, you have to try learning. Otherwise, you will never learn. And every time, whenever, even at the age of 50 or 60, you will tell that, oh, it is very tough and I can't understand. You have to understand. You have to try. Wherever you don't understand, let me know. But don't discard that. Oh, I don't understand. That's why I don't want to see that. This is a very bad concept. Onnesha, what was your school?
Sir, St. Joseph School.
Saint you are from Saint Joseph School, and you are writing that you can't understand what he is saying in American English.
Sir,
This is
actually,
really very unfortunate. Yeah,
when the video is presenting, my net is not very great, so I
that is a
miss
different
some
thing.
words. So,
That's a different thing. So why you are writing that you couldn't understand? Your network is
it was
different.
difficult to catch some words
What?
because he was speaking. So it was difficult to catch some words because he was speaking fast and it
Do
was
you
like
think that
lagging.
do you think that in your every class you understand all the words of your teacher?
No, sir.
Then what's the difference here? Look, there are a few students who wrote the name. Sohini, you are from which school?
Sir, I am from Anandamad Vidyapit.
Yeah, Anandamot Vidyapit. You had your English language?
Yes, sir.
Do you listen to English news reading?
No, sir, generally not.
Yeah, then you will be always under your closed door. You will never come out of the door opened. Okay, Khijir Alam, you are from which school?
I'm from Chatai High School.
What?
In my village. Chatai High School in my village.
Yeah, so did you have English language?
No, sir.
No, then I can't help you. If you did not read English, then how did you get a chance in the Jadavpur University? Because English language is one of the the mandatory language which you must have in your school. Is that right or no?
Yes, sir.
So you don't have any English language in your schools?
Sir,
Look, if you don't have English language in your school, I am really helpless. You have to understand.
I will try.
You have to try. I will no, not I will. I must try.
I must.
Yes, Arpan, which school you are from?
Yes, sir. Jadavpur Vidyapit.
Jadavpur Vidyapit is a very good school, and if you say like that I cannot understand the English of American, it's very poor. You have to try it. Supratik, you are from which school?
Yes, sir. I'm from Noyati Narendra Vidyaniketan.
Yeah, did you have your English language?
did you have your English language? Yes, sir.
Yeah, so what's wrong here?
What's wrong here?
Tell me which
I'm
part
facing some difficulty to understand.
difficult to understand which part?
There is something he's setting up some disc-like thing with too many holes. From there, it is difficult to understand.
Okay. What is the name of that?
I don't know, sir. Sorry.
I don't know. So who knows? What is the name of that? Anybody? Nobody. That means nobody listens to it sincerely. This is dividing head. Okay? I'll repeat this once again. And everybody has to understand that and let me know. Yeah, where is that? I have to check. Could you understand this part? Could you understand this part?
Started on this one.
No, sir.
Okay, could you understand up to this?
So we'll just take this apart.
Up to this, could you understand?
Held firmly in place now.
Could you understand up to this?
Yes, sir.
What is it? Tell me.
Now we just need to get our foot stock on here.
Sir, it is the workpiece that is being actually fixed.
This is the workpiece? Is it the workpiece?
Yes, sir.
Acha. Then,
So we got our foot stock installed now. And
so you know that you are telling about this disc, right? This disc. Is that right?
Yes.
Yeah.
Yes.
This is the dividing head, and you have to understand the mechanism very sincerely. So now I am repeating it. Try to understand and listen carefully and sincerely. And if there are any problem, let me know once again. All right?
In line, so we're good to go there. Everything's tightened back up. So that's done. Next thing we need to do is get the right index plate in here for cutting 27 teeth. And I went and looked at my chart and...
yeah, what he said?
Index plate, sir.
He's going to insert right index plate and he has to see the chart.
And he is going to cut how many teeth? 27 teeth. Yeah, you could understand. And I'm quite sure that everybody will understand only if you sincerely listen to it once again.
What I need to do that is actually a plate that has a 27 hole pattern in it. So I got 27 on this one. The one that's in here is not a 27, so I need to change these plates out real quick. So we'll just take this apart and do that. We'll start by taking the handle off. There's a clip here that holds the scepter on there, so we need to take that out. Let me knock that clip out. Alright, we'll pull the sector out. And then we'll remove the screws on this plate. And now we can knock this one out. There it comes. Set that one aside.
So what he has done?
Changing
What?
the index.
What he has done now?
Sir, change the index plate.
He has changed the index plate because the previous plate will not allow to cut 27 teeth because the number of holes matter. So that's why he is putting a disc which will match the cutting of 27 teeth. Okay, just listen.
Trying to line up my screw holes back there. Let's get all these started and then we'll get it in all the way. Alright. Got that plate back in there. Next thing that goes back on is the sector. And let me look and see. I know it's 1 revolution in some number of holes. It's 13 holes. So I'm going to go ahead and adjust this. Grab a Sharpie pen. Alright, so this is the 27 line here. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Started on this one. Loosen the screw up. And I'm going to spread this out over here. And you just use this little piece here to help you get on the right tooth each time. So that's now set. We'll put our clip back in here that holds this in place. There's a little detent here. So I'm going to put that up. And we'll just press that down. That's in place. And put our handle back on. And we'll tighten that back up. And then we need to make sure we're in the right hole pattern and we're off one. So let me loosen this up. And I'm going to slide this down. We'll get that one into the right pin there. And tighten it back down. Alright, so I'm going to pull this around here. And to get our 27 teeth, we'll do one full revolution and then 13 holes. Well, there. I'm not doing it for real now. We'll move our scepter around. This little tight one. And there. So on, so on, so on. So we're ready to start building our arbor now. I've got a 1 inch.
So, could you understand this? What he said? Anisha?
Sir, I again lost my internet for a while actually.
What?
Sir, I lost my internet for a while, so I missed
Forget it. Yeah, Ritik?
I understood some part.
Okay. So, which part you did not? Okay. So, ask some other guy. Who else are there?
Revolution in some number of holes. It's 13 holes. So I'm going to go ahead and adjust this. Grab a Sharpie pen. Alright, so this is the 27 line here. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We started on this one. Loosen the screw up. And I'm going to spread this out over here. And you just use this little piece here to help you get on the right tooth each time. So that's now set. We'll put our clip from here. And to get our 27 teeth, we'll do one full revolution and then 13 holes. Well, there. I'm not doing it for real now. We'll move our scepter around. This little tight one. And there. So on, so on, so on. So we're ready to start building our arbor now. I've got a 1 inch arbor here. Just wipe that down. Make one way or the other. We put the overarms a line on there. I'm very close to being right in the center. And it'll kind of self-align on there. But before I do, I'm going to squirt a little oil up in there just to go ahead and get me started with some. Alright. Now I'll just pull the overarm support onto that bushing, slides up on there just as nice as can be. And that's good. And I'll tighten down the overarms on the top now. Way of doing it, this method's always worked for me. I know a lot of other shops that use this. And basically we're just going to find the top of that shaft by finding where it hits out on there. So just eyeballing it, I'm very close to being right in the center. I'm going to raise this up until I just barely start to get a cut on there.
No, competition is
that should be pretty close.
না এর আগের বার যেরকম করেছিল একটা আলাদা শীট এটা তো করেছেন নিশ্চয়ই
Alright, I'm barely touching it right
কম্পিটিশন
now. And now what I'm going to do is I'm just going to take my
দেখুন
table
এতে ওই
and I'm going to move it back and forth across the top. And what that does is it makes a mark. And it
না
kind
না
of
না না সেটা বলছি না আপনি
is
যে অ্যাকাউন্টটা
somewhat
তৈরি
diamond
করলেন
shaped.
সেইটা
And the
আপনি
very
আগের বারেরটা
highest
দেখুন
point
নাহলে
is
আমি
going to be
আরেকবার
kind of
পাঠিয়ে
in the
দিচ্ছি তাহলে বুঝতে
tops of
পারবেন
that
আমি কোন
diamond in there
ডকুমেন্টের
because it's
কথা
below a
বলছি
circle.
মানে ওই
And
সার্টিফিকেটের
now what I'm
সঙ্গে
going to do is
ফর্ম 16 এর সঙ্গে
just come
দেখুন
in here and I'm going to
ও
eyeball
আরো
this thing and get it lined
দুটো
up
ডকুমেন্ট
off
পাঠিয়েছে
of those
যেটাতে ও
marks.
অ্যাকাউন্টসটা তৈরি করেছিল
So I'm going to grab a
কত
little
ইনকাম
flashlight where
কত
I can see what
এই
I'm doing a little
সমস্ত
bit better.
ফর্ম সমস্ত কিছু
Actually, I
পাঠিয়ে
can
দিয়ে
see
আপনি
the width
দেখেননি
of my tooth is just right on that
আমি
mark.
আমি
That's
পাঠাচ্ছি
right where I
আরেকবার
need
আপনি
to
দেখে
be.
নিন তাহলে
What I'm going
বুঝতে
to do is I'm
পারবেন
going to go ahead and I'm going to lock my table in place there so it's not going to go anywhere. And we're going to start with this as being a 0 on my height. It's probably not a perfect 0, but again, we're going to measure across ends to find our exact depth of cut that we need to make. We're going to do this in 2 passes. So anyway, I've got that done. I'm going to go get an indicator set up here. And according to my worksheet, we need to
তাহলে
raise
ওই
the
দুটোই
table
দিতে
up.
হবে না ওই দুটোই দিতে
What
হবে
was it here? Let me look on my worksheet.
যে দুটো অটোমেটিক্যালি এলো সেই দুটোই নিতে হবে আমরা সেটা
137,000.
হয়তো
So we're
হিসেবে
going to
ভুল
move the
করেছি
table up 100,000. Do that in the
আপনি
first
ওই
pass.
দুটোই নিন
Get
ওই
measure
দুটোই
across
নিন আর
ends,
আপনাকে
determine
একটা
the
আগের
actual
বারের যে অ্যাকাউন্টস
amount we
তৈরি
need to come
করেছিল
up, and then we'll
একটা
finish it
ব্যালেন্স
up on
শিট তো
that. So let me
থাকবে
grab an indicator,
ইনকাম
and
এক্সপেন্ডিচারের
we'll
একটা
get our
ব্যালেন্স শিট
first
তো
step
থাকবে
set here. And I got my indicator set here. We need to come up 100,000ths, which will be 1 revolution on that dial. And so up we go. Right there. I'll drop it down. Oh. All right.
অ্যাসেট লাইবিলিটি হ্যাঁ হ্যাঁ ওই শুনুন এর আগের বার যা ছিল
This machine's got a little
সেইটাই
wear on
ক্যারি
it, so when you
ফরওয়ার্ড করুন
tighten
কারণ
the
আর কিছু করে না
the table, it usually is going to bend it in just a little bit, but we got it on 0 there. There's a little trial and error involved, but no big deal. So I have my table locked
আমি
in
ঠিক আছে
both the directions except
যেটা
my feed
আগের বার
direction.
ছিল না আপনি সেই
And we'll go ahead and take our
ডকুমেন্টগুলোই পাঠান
indicator
সেই
off.
ডকুমেন্টগুলোই তৈরি
And
করে
we should
পাঠান
be
আমি
ready to
পাঠাচ্ছি
make our
আপনাকে
first
আগের বার
pass.
যা যা ছিল দেখুন
So away we
সেই
go,
অনুযায়ী
guys.
আপনি এইবারেরটাও তৈরি করে পাঠান
I've got
আমাদের
my
তো কিছু
spindle speed set on, what is that?
আমি আপনাকে পাঠাচ্ছি ওটা আছে
93
দেখুন আমি
RPM,
আপনাকে
right?
পাঠাচ্ছি
100
আবার
RPM.
আপনাকে পাঠিয়েছিলাম আবার পাঠাচ্ছি
And I've got my feed rate right now is on 1 3/8 per minute. And we're just going to see how this sounds, see how it cuts, and go from there. So that's kind of normal on a horizontal mill. And another reason why you need to make a cut and then go back and really check your measurements afterwards. Alright, we're through our cut. I'm making some marks here on my table where I can quickly go to them. So, back out of that. Stop our feed. We're ready to rotate our part now. Over on the dividing head, you can't see this. Then we'll do our 1 and a partial turn. Go there, lock it down, and we're ready to make our second cut.
See, however, this is the way once the one teeth is cut, then with the help of the rotation in dividing head, you will get the second position of the second gear cut. So you are not to rotate this separately. So this spindle is stacked to the dividing head in such a manner that this will rotate as per the requirement of the number of teeth. Okay. So however, as you don't understand, I am not showing this more, and whatever I showed you and I explained you, on the basis of that you have to make a PPT, whatever you understood, because I cannot make you understanding English at this stage of third year of your class. So that you have to. All right. So
I have a question.
yes.
We have to rotate the job manually, or I mean, there is an indicator. With the help of that indicator, we can understand the angle with which it is rotating, or not.
Manually, there is a handle you have seen
Yes, yes, sir.
in the dividing head, and the dividing head is set so that the rotation given to the dividing head gives the rotation to the job at the required place, location. And you are not to rotate again the job, because once the dividing head handle is rotated, that is automatically rotated and location is set. So only thing is that you have to after rotation you have to cut the next cut for the next teeth. Okay. So what I'll ask you to yeah. Anything else? Anything else? All right. So now Dinesh, you are here.
Sir, next class is held in offline or online?
I don't know. That will be dictated maybe in next couple of days. This week only we'll know that. All right.
Okay, sir.
Dinesh, are you there?
Yes, sir, I'm here.
Yeah. So now you ask these students who could not make the presentation last class. So one by one you start presentation for them, maybe for 5 minutes. And there were two topic. One is the drilling, other is the milling. So you can select any of those and then start. Allow them 5 minutes. Okay.
Hello, sir. Hello.
Yes.
Sir, I have a question, sir. That the video shown us that the indexing method is the complex indexing method, isn't it, sir?
I don't understand. What is complex?
Sir, the method of the rotating the arm of the dividing head that we are I think we are read it at the last semester. Here the we said it at the indexing method. So that here the explain in the video. So I think that is the in compound indexing method.
Okay, all right. Yeah, Dinesh, you can go ahead.
Okay, sir. Roll number 56, Supratik Malik. Are you ready with your presentation?
And just give me a minute. I will just present. Yes.
Okay, fine. Go with drilling machine.
Okay, sir. Is my screen visible, sir?
Yes, your
okay. So I will start my presentation in the drilling machine. So drilling machine is a metal removing or cutting process in which the tool uses a drill bit to cut a hole of circular cross section in solid material. This is the schematic diagram of a drilling machine, and in the right side there is a real drilling machine. These are the parts of a drilling machine like base, column, table clamp, electric motor, etc. Then the components of a drilling machine, there is base. It is the base, or it is made of cast iron, and it provides support to the whole machine. And then there is column or pillar. The column or pillar is situated on the side of the base. In general, we use a radial column so that the movement of the arm is possible in clockwise or anti-clockwise direction. So the column or the pillar help us to slide the job or the work table, and it also support the workpiece. Then there is table. The table is mounted on the column and is provided with T-slots for clamping the work directly on its face. A table is round or rectangular in shape. Then there is radial arm. It is mounted on the column and extend horizontally over the base. It has guideways on which drill head slides. Then drill head, it is mounted on the radial arm and drives the drill spindle. In some of the drill machine, the drill head may be adjusted up or down for accommodating different heights of the work in addition to the table adjustments. The spindle, it is a circular taper shaft which help to hold the drill chuck. It made with high carbon chromium steel or HSS or stainless steel or steel alloys. It transfers the rotary motion from drill head to drill jigs. The chuck is mounted on the lower end of the spindle. It holds the drill jig. Electric motor is supply the power to the drill machine and to the spindle. Pulley or gear. The pulley or gears is used to transmit power and also for getting different speeds. Then how a drilling operation takes place. So we will mark a point on it on the workpiece where the holes are going to be made. Then we use drilling machine to set up the components and take a sharp cylindrical multi-point cutting tool, insert it inside the chuck and fix it tightly there. Thirdly, put the workpiece block on the table and clamp it. Fourth, move the table along the column until a specific distance between the tool and the block. Lastly, we switch on the power supply. Then the tool begins to rotating. The hand hammer manually we can give the hand feed, or in some drilling machine the feed is automatic. By this way we can complete a drilling operation. Then types of drilling machine. So there are several types of drilling machine available in the market. So some of are the sensitive drilling machine, vertical or pillar type drilling machine, radial arm drilling machine, gang type, multi-spindle, numerically control, etc. So sensitive drilling machine. The sensitive drilling machine has only a hand feed mechanism for feeding the tool into the workpiece. It enables the operator to feel how the drill is cutting. Accordingly, he can control downhit pressure. Then there is vertical or pillar drilling machine. Vertical or pillar drilling machine is freestanding, as is of a far heavier construction, able to take larger drills. It has a heavy frame to support a wider range to work. The table height is adjustable and the power, speed and feeds are available. So then there is the radial arm drilling machine. The radial arm drilling machine is freestanding and the workpiece is clamped in the position on the base. It is used for large or heavy work. Then there is numerical control drilling machine. A numerical control drilling machine can automatically change tooling with a turret or automatic tool changer. So there is the gang milling machine which is shown, and multi-spindle drilling machine which can be used in several operations. Then the advantages of the drilling machine are we can drill a hole with high speed. It gives us a high output. The drilling machine is easy to operate and it has the high flexibility and also the low maintenance cost and longer life. Then the drill bits. So the drills are cutting tool used to remove material to create holes, always to circular cross section. So this is a diagram of a drill bit, and it has mainly two parts. One is body and one is the shank. So in there is part like point, flutes, land, body clearance. It also have some point angle and helix angle, which is shown in the right diagram. So some of the following parts of the drills are body, point, shaft, tank, flutes, land, body clearance, wave neck, etc. So these are the parts like body, point. The body between the shank and the point drill is called the body. So then there is different type of drill bits. So in the market more than 20 types of drill bits are available. So some of them are the flat drill. This type of drill is generally made by beating slender sticks or high carbon steel. Their cutting edge is ground and then hardened and tempered. It can be made easily in the shape of size. Then straight fluted drill. A straight fluted drill consists of grooves or flutes running parallel to the drill axis. A straight fluted drill can be thought of as cutting tool with zero racks. This type of drill is not available in standard practice as the chip do not automatically pop out of the hole. Then there is a twisted drill bit. So the twisted drill bit is the most popular and commonly used drill bit in the workshops. The twist and thick drills are used for boring holes quickly, clean, and of the accurate size. Then the center drill, it is also known as a combination drill. On both side, on both its ends, a cutting point is made and its middle portion is planed. The drilling and counter sinking can be performed simultaneously with this drill. Then counter sinking drill, we can perform the counter sinking operation with the help of this drill bit. Then counter boring drill, we can complete the operation which is counter boring by help of this drill bit. So when Allen screws are fitted, counter boring is done with this drill. This type of screws are also fitted like the counter screw on the surface of the job. Then there is other types of drill like spheric drill or step drill and masonry bead. So there are other drill like auger drill, glass bead, hole saw, etc. Now the drilling operations. Drilling is the operation of producing cylindrical holes. So this is the most common type operation we can perform with the help of drilling machine. So the drilling is one of the simplest operation. We just hold a workpiece and then use a drill bit to drill a hole. Then there is reaming. So reaming is an accurate way of sizing and finishing a hole which has been previously drilled. In order to finish a hole and to bring it to the accurate size, the hole is drilled slightly undersized. So this is the drilling operation and reaming operation, and this is the reaming tool. The speed of the spindle is made half that of the drilling automatic feed may be employed. The tool used for reaming is known as a reamer, which has multiple spindle edges. Then the boring. So boring is basically the enlarging the hole that was previously made. Boring is performed in a drilling machine to enlarge the body hole. Means the adjustable cutting tool, only one cutting edge. This is necessary when the suitable size drill is not available or where the hole diameter is so large that it cannot be ordinarily drilled. Then there is counter boring. When we have to fit a nut bolt, then we have to counter both the job of making a cone-shaped enlargement of the end of a hole, provide a recess for a flathead screw or countersink rivet filled into a hole. So we need to use the countersinking bit to complete the operation. And this is the presentation of mine. Thank you.
Okay. So, Mr. Malik, can you explain what are the parts of building?
Sir, can you repeat the question?
What are all the parts of drill bit?
There are generally two parts of a drill bit. One is the body, one is the shank. So shank is the base part, like what hold the chuck. We feed the shank into the chuck and it holds the drill bit. And in the body there are several parts like the point or the tip, and there is the flute, which is the groove type of part, and there is the land, and this is the part of a drill bit.
Okay, thank you.
Okay.
Okay, SK Rahul Amin, roll number 49. Are you ready for the presentation? Rahul Amin. Okay, Suryayan Banerjee, are you there? Roll number 53.
So there has been a power cut in my locality. So my laptop, the charge in my laptop is gone, sir. Sir, I was doing the class up till now, and just now it went away. The charge.
Okay, so you are not able to give a presentation now.
Yes, sir.
Okay, can you make a favor? You better call sir and inform this.
Okay, sir. Okay, I'll call sir and inform this.
Okay, you better do that. Okay, Abhilash Kar, are you here?
Yes, sir, I am here.
Are you ready with your presentation?
Yes, sir.
Okay, you make a presentation. Yours will be milling machine.
Okay, sir.
Okay.
Sir, is my skin is visible?
Yeah, it's visible.
Good morning. My name is Ubhilas Kaur. Now I am presenting a presentation on milling machine. Milling machine is a type of machine by which we can remove materials from a workpiece and by feeding the work over against a rotating multi-point cutter. And the metal removal rate is higher, very high, as the cutter has the high speed and many cutting edges. So this is the part of a milling machine. So the first part is the base. So this is the base. The base is mainly made up by cast iron for its high compressive strength and high vibration absorbing properties. And the next part is the column. This is a column. In the column, we can move this table part or the workpiece up and down. The next part is the knee. Knee is the part which support the table and the workpiece. And then the next part is the saddle. The saddle is the part in which the workpiece is fitted. Table. This part is called the table. This and the overarm. This part is the overarm part where the cutter is fixed, and also the spindle is present in this part. Other bar is present in the overarm part. There and there is a ram. This is a ram, the milling head and the spindle. So this is another schematic diagram of the parts of milling machine. So this part is called the arbor part, and this is a milling cutter, and this part is the overarm part, and this is the arm bracket for support the arbor. This is the vice. In the vice we can adjust the tool in the table, and there is a wheel. By this wheel up and down in the column. So which I have described in the figure. All of these are written here. So now different type of milling operation. The first is the plain milling or the slab milling, and then is up and down milling, face milling, edge milling, form milling, angular milling, gang milling, straddle milling, rope milling, gear milling, side milling, and T-slot milling. The first is the plain milling. The plain or slab milling is the process in which the plain, horizontal or the flat surface are produced, which are parallel to the axis of the rotation. So this is the axis of the rotation, and the rotation of the cutter is also parallel to it. A peripheral mill cutter is used for this operation. So this is a peripheral milling cutter. So now this is up milling and down milling. Up milling is a method by which with the cutter and the workpiece both move in the opposite direction. In this case, the workpiece move in this direction, and the workpiece move in this direction, and the cutter is rotating is clockwise the direction. So they are in the opposite motion, and the chip and this is a chip which are formed in this process. The down milling is the method in when the both the workpiece and the cutter are in the same direction, are motion in the same direction. So this is a down milling. Face milling, it is a type of the milling in which the layer of the material is removed from the face of the material. So this is the face of the material. By this milling operation, we can remove material from the face part of the material. The end milling cutter is used for the operation. The tool is end milling cutter, and the face milling operation, the teeth of the cutting are present on both the periphery and the face of the cutter. now came into the end milling operation. End milling is a combination of the slab milling and the face milling operation, and used for creating slot in the workpiece and mostly used for handling the complicated profiles. Gang milling. Gang milling is a type of milling operation in which multiple cutters are being mounted on the same arbor to produce the desired shape of the workpiece. So this is a arbor, and there are like the multiple milling cutter are present. Saddle milling. So this type of milling process in which the milling is performed on two surfaces simultaneously. T-slot milling is the unique example of the saddle milling. So these are the two milling cutter, and the distance between two is called spacer, and this is the arbor. Application of milling operation. Milling is used for machining flat surfaces, slotting, counter surfaces. It is also used for making complex and irregular areas, revolution surfaces, gear cutting, machining external and internal threads, machining helical surfaces of various cross section and many more. And we can use the milling operation for making the gears. Thank you. Yes.
Okay, Abhilash, can you explain what are all the operations we go for down milling?
Sir, operation in down milling, sir. At first, sir, the gear of making the gears in the down milling, and also, sir, the T slot also we can make by down milling.
Yeah, why we going for down milling instead of up milling?
So sorry, sir, I don't know.
Sorry?
Sir, sorry, sir, I don't know.
Okay, fine. Okay, thank you. Then, Arnav Dutta, are you here?
Thank you, sir.
Yes, sir.
Abhilash, are you there?
Yes, ma'am. Yes, ma'am.
Oh yeah, I would like to ask one question because I really want to ask. You have mentioned in the diagram that the milling vise. Can you explain why it is used?
Sir, milling vise is used to hold the workpiece, and we can adjust the workpiece as per our requirement for the cutting operation, milling cutting operation.
Okay. Please go ahead, Dinesh.
Yeah, okay. Okay, Arnav Dutta, are you here?
Yes, sir.
Yeah, are you ready with your presentation?
Yes.
Okay, you can make a presentation on drilling machine.
Okay, sir. Okay, I'm going to present about presentation on drilling machine. Drilling machine is a machine in which holes are made on the workpiece using a multi-point rotating tool called drill bit or a twist drill. Drilling is a single-purpose machine tool, as its main purpose is to make holes in the workpiece. The machine consists of a spindle which provides the rotatory motion to the drill bit, which finally makes the hole in the workpiece or the job. And this is the diagram of a drilling machine, which consists of the base, which is generally made of cast iron, and the base acts as the support for the column, which holds the overhang, which holds all the mechanism, like the gear mechanism and the feed mechanism. And the overhang also consists of the spindle, which gives the rotatory motion to the chuck, and the chuck holds the drill bit, which performs the operation and the workpiece is clamped on the work table, which has a vise which holds the given job. Now, working principle of a drilling machine. First, the power is given to the motor, which in turn rotates the spindle, and thereby the step pulley attached to it also rotates. On the other end, one more step pulley is attached, that is inverted, and which can help in increasing or decreasing the speed of the rotational motion. And the pulleys are connected using a V-belt, as V-belts helps in better transmission of power and better power transfer efficiency. The drill bit is placed in the chuck, which rotates in connection with the spindle. As the pulley rotates, the spindle also rotates, which rotates the drill bit. Now with the rotation of the hand wheel, the spindle moves up and down in the vertical direction, and it gives us the necessary amount of feed that is required for the for completion of the given job, and also helps in making the hole on the component that is placed or clamped on the machine vise. Now, the different types of drilling machine. Different type of drilling machines are radial drilling machine, upright drilling machine, multi-spindle drilling machine, sensitive drilling machine, portable drilling machine, gang drilling machine. Coming to radial drilling machine. Radial drilling machine has a single spindle, and it is used to handle large and heavy workpiece, which cannot be done by a simple drilling machine. It consists of a swinging arm which can go through an arc of 180 degree or more. Now, sensitive drilling machine. A sensitive drilling machine is hand-fed drilling machine, and in this drilling machine, the operator gives the hand feed, and he can sense the drilling motion while giving the feed due to hand feed. Now, upright drilling machine. Upright drilling or column drill is similar to sensitive drilling machine. The only difference is that the power feeding mechanism is used for the rotation of the drill. The machine is mostly suited for heavy work, and the size of the work that can be accommodated is limited by the distance between the spindle and the column. Multi-spindle drilling machine. A multi-spindle drilling machine is used when we require a number of holes in a single workpiece, which can be done in a single operation, and hence improving the time efficiency. Gang drilling machine. Gang drilling machine it consists of 2 or more drill heads mounted on the same table. These can run simultaneously or in sequence. This gang drilling machine is mostly used when a number of operations are required to be done on a single workpiece in consecutive manner. It is used for a straight line, multiple hole drilling. Its application it also has application in pipes, channel, casting plates, and angle. Now, coming to portable drilling machine. Portable drilling machine it is a small drilling machine which can be used for doing some small works like drilling holes in various places in which we cannot use the large heavy drilling machines. Now, operations performed by drilling machine. First operation is drilling. In this operation, holes are made on the surface of the workpiece using the drill bit, and it is called a drilling operation. In boring operation, already made hole is enlarged using boring. Now, in reaming is a finishing operation. It is used to finish an existing hole for giving it a better surface finish. Now, tapping in this operation, internal threads are made using a cutting tool called tap. In counter boring, it is used to enlarge a certain part of a hole which is already made. In countersinking is used to enlarge the end of a hole and give it a conical shape for the end a shorter distance. Now, these are the various diagrams of all the operations for reaming, tapping, counter boring, countersinking, central drilling, and spot facing. Spot facing is used for drilling the surface so that a bolt can be fit correctly. Now, drill bits. It is a tool. It is a multi-point cutting tool. It is made of high carbon steel or alloy steel for drilling. The drill bit is rotated with a downward press, which causes the tool to penetrate into the material. Now, for holding a drill bit, a holding device is used, which is known as drill chuck in a drilling machine. Now, this is the diagram, detailed diagram of a drill bit. This is the shank, and this is the helix angle. This This is the lip relief angle, and then the angle made by the tip of the drill bit is known as point angle. Now the angle made by the cutting lip and the chisel edge is known as the chisel edge angle. Thank you.
Yeah, thank you. Can you tell me what is the difference between counter boring and counter sinking?
In counter boring is used to enlarge a certain part of the hole. It generally does a cylindrical hole, while in counter sinking a conical certain part of the hole is made to give it a conical shape.
Okay. Tuli, do you have any questions?
Yeah, I have one question. Arnav, can you tell me one advantage of drilling machine?
Advantage? Drilling machine, it has low maintenance cost, and it is easy to operate.
Okay. Any more?
No, I can't remember any. No.
Finish. Please go ahead.
Yeah. Thank you.
Okay. Arif, are you here? Arif Billah, roll number 57.
Yes, sir. Yes, sir.
Okay, you can make your presentation on drilling machine.
Okay, sir.
Yeah, before that, Suryayan, have you informed this to sir? Suryayan Banerjee, are you here? Hello?
Dinesh, I can see his name in the chat, in the group, in the meeting.
Yeah.
I think he is not answering.
Okay, SK Rahul Amin, are you here?
Yes, sir. Yes, sir.
Okay, be ready. Are you ready with have you prepared any presentation?
Yes, sir.
Hello, sir.
Some network problem.
Okay, fine. Be ready with your presentation. You'll be next.
Is my
screen? Yeah, it's
screen
visible. Make it full screen.
Okay, sir. Thanks. Thank you, sir. Okay, sir. My name is MD Arif Billah, roll number 57. I am going to presentation drilling machine. This is the drilling machine introduction. Drilling is an operation through which holes are produced in solid metal by means of a revolving tool called drill. Since it is not possible to produce a perfectly true hole by drilling, it is considered as halving operation. Obviously, therefore, where a very close dimensional accuracy is to be maintained, this forms only the basic operation. This is the structure of a drilling machine. The basic parts of a drilling machine are a base, column, drill, head, spindle, etc. The base made of cast iron may rest on a bench, pedestal or floor, depending upon the design. Larger and heavy duty machines are grounded on the floor. The column is mounted vertically upon the base. It is accurately measured and the table can be moved up and down on it. The drill spindle and an electric motor and the mechanism meant for driving the spindle at different speeds are mounted on the top of the column. Power is transmitted from the electric motor to the spindle through a belt like V-belt. This is the picture of a drilling machine with all component marked as well. You can see this is the details about a drill. A drill bit, like a drill, is a tool used to organize a hole is in a solid material. A helical groove known as flute is cut along the length of the drill. Different type of drills. There are different type of drills like flat drill, straight flow drill, twist drill, center drill, etc. They are made of high speed steel and high carbon steel. There are two types of twist drills, mainly straight shank drill, taper shank twist drill. The diameter of the straight shank drill range from 2 to 16 millimeter. Taper shank is provided on drills of larger diameter. Taper shank is used lead and straight shank is used in drill machine. There are different type of parts of twist drill, like axis, body, shank, tank, point, lip, land, fruits, etc. Axis, it is a longitudinal center line drill running through the center of the tank, and the chisel edge. Body, it is a part of the drill from the extreme point to the common segment of the neck if present. Otherwise, it is the part extending up to a common segment of the shank. Helical grooves are cut on the body of the drill. Shank, it is the part of the drill by which it is held and driven. Tank, the flattened end of the taper shank is known as tank. It is meant to fit into a slot in the spindle or socket. It ensures a positive drive of the drill neck. It is the part of the drill which is diametrically undercut between the body and the shank of the drill. The size of the drill is marked on the neck. This is the point. It is the serpent end of the drill. Serpent end of the drill. It is shaped to produce leaves, face, flanks, and chisel edge. Leaf, it is the edge from the intersection of flank and face. There are two leaves and both of them should be of equal length. Land, it is the cylindrically ground surface on the leading edge of the drill flutes adjacent of the body. Plane surface flutes. The grooves in the body of the drill are known as flutes. Flutes from the cutting edge on the point that allows the tips to escape and make them curl. It permits the cutting fluid to reach the cutting edge, and there is the nomenclature of the drilling tool. Like there is two parts of a drill bits, like shank and body. There is so many things you can see. There's tank, drill axis, flute, there is the teeth, cutting diameter, etc. And different type of drilling machine. There is a different type of drilling machine